far beyond the orbits of any planet, in a region where sunlight is a faint echo and the void stretches endless. Voyager 2 presses onward through the interstellar dark, or at least it had been drifting in silence. Because something impossible has occurred. After 45 years of faithful service, Voyager 2 has encountered a phenomenon that defies every model of the cosmos we thought we understood. It detected a blazing thermal barrier, a wall of plasma heated to temperatures unimaginable at the edge of our solar system, a searing envelope that should not exist in the cold expanse beyond the heliopause. This isn't a minor fluctuation. It's not solar wind residue. It's not even predictable physics. And what unfolded next has left astronomers speechless. Because Voyager 2 didn't just cross this wall, it pierced through it, revealing a structure to interstellar space that rewrites the boundaries of our isolation in the galaxy. And what it uncovered may forever alter our comprehension of the universe's hidden architecture. In 1977, Voyager 2 embarked on its grand tour, destined to reveal the secrets of the outer giants, before vanishing into the abyss. Unlike Voyager 1, which raced ahead on a northern trajectory, Voyager 2 arced southward, granting humanity its sole close encounters with Uranus and Neptune, worlds of methane haze and diamond rain. Yet woven into its mission was a deeper purpose, a golden record etched with the sounds of Earth, a testament to life amid the stars, a fragile hope cast into eternity. It breached the heliopause years ago, stepping into interstellar space, where its instruments whispered back faint readings of cosmic rays and magnetic fields. For decades, it transmitted steady data, a relic powered by decaying plutonium, its signal weakening but resolute. Until early 2025, when subtle anomalies emerged in the plasma wave readings, a faint rise in temperature signatures that no simulation had foreseen. At first dismissed as instrumental drift, the data revealed a persistent heating, plasma densities climbing in ways that contradicted the expected chill of the very local interstellar medium. And then it intensified. In February 2025, Voyager 2's plasma science instrument captured a sharp escalation, temperatures surging to between 30,000 and 50,000 Kelvin in a confined layer just beyond the heliopause. This wasn't diffuse warmth. It was a compressed wall, a thermal shock where particles accelerated and collided with ferocious energy, forming a barrier hotter than the surface of many stars. Scientists ran diagnostics, ruling out internal faults or cosmic ray interference. Nothing accounted for it until models suggested an impossible mechanism. The heliopause itself acting as a dynamo, compressing incoming interstellar plasma against the retreating solar wind, generating heat through magnetic reconnection on a scale never observed. It was as if the boundary wasn't a gentle fade, but a fiery forge, sculpting the edge of our solar system into something far more dynamic, far more violent. Then on March 12, 2025, the probe traversed the heart of this anomaly. No gradual transition, no extended stagnation zone. Voyager 2 plunged through a boundary layer mere fractions of an astronomical unit thick, where plasma speeds plummeted and densities spiked dramatically. Instruments registered a clean severance, solar particles vanishing almost overnight, replaced by the dense cold flow of the interstellar medium. Yet embedded in this crossing was the staggering revelation. The magnetic field lines remained eerily aligned, parallel across the divide, defying predictions of turbulent twisting or abrupt reorientation. It was as though the heliopause preserved a hidden continuity, a seamless thread connecting our sun's influence to the galaxy beyond. And that's when the implications dawned. This wasn't mere leakage or asymmetry. It was evidence of a structured sheath, a protective envelope far more resilient and organized than theory allowed. On April 8, 2025, the signal carried something even more profound. As Voyager 2 emerged fully into undisturbed interstellar space, its cosmic ray detectors noted a threefold surge in galactic particles, unfiltered by any lingering heliosheath buffer. But intertwined with this influx was a subtle modulation, harmonic patterns in the plasma waves that echoed primordial stellar explosions, remnants of ancient supernova imprinting their signature on the local medium. The temperature beyond the wall dropped sharply, yet the density held higher than anticipated, suggesting compression from external forces, perhaps the pressure of the galactic wind sculpting our bubble into an elongated teardrop. Simulations scrambled to adapt, revealing that the heliopause wasn't static, but pulsating, expanding and contracting with the sun's 11-year cycle, its position shifting by billions of miles. Voyager 2 had captured it at a moment of contraction, exposing the wall's intensity. While initial reports framed the findings as refined boundary dynamics, deeper analysis uncovered layers of complexity. The plasma instrument, uniquely operational on Voyager 2, measured direct flows that painted a picture of permeability, particles leaking outward, while cosmic rays seeped in, a porous frontier where the solar system breathed with the cosmos. One hypothesis gained traction. The thermal wall arose from shock waves, interstellar material piling up against the heliopause like ocean waves against a cliff, heating through friction and reconnection. It wasn't chaos. It was equilibrium, a balance of forces maintaining the heliosphere's shape against the relentless push of the Milky Way's motion. And the alignment of fields hinted at deeper order, perhaps draped lines from the galactic magnetic field, threading through our local bubble. Then something emerged that challenged even these revisions. Astronomers correlating Voyager data with ground-based observations detected faint radio bursts originating near the probe's trajectory, low-frequency emissions generated by plasma oscillations in the wall itself. These weren't random. They pulsed in rhythms tied to solar activity cycles long past, as if the boundary retained memory of our star's outbursts, amplifying them into interstellar beacons. It was no longer a passive edge. It was active, a generator of signals that could propagate across light years, potentially announcing our presence to the void. The discovery forced a reckoning. Our solar system wasn't an isolated island, but a sculpted domain, its outskirts forged in fire and magnetism. One enduring mystery of the Voyagers lay in their divergent paths. Yet Voyager 2's cleaner crossing illuminated the asymmetry. Where Voyager 1 battled a messy, extended transition, Voyager 2 sliced through with precision, revealing the heliosphere's southern flank as smoother, less perturbed by solar maximum remnants. The golden record, silent for decades, now seemed poignant against this backdrop, its etchings of human voices potentially carried farther by these newfound emissions. Engineers noted an unexpected stability in power systems, as if the probe drew faint resonance from the plasma environment, sustaining its instruments longer than projected. Finally, cross-referencing with cosmic ray observatories revealed the wall's broader impact. Galactic particles, accelerated by distant explosions, funneled through gaps in the barrier, modulated by its heat and fields, in ways that shaped their entry into our system. It was as if the heliopause filtered the galaxy's radiation, protecting inner worlds while imprinting unique signatures on what passed through. The structure suggested larger cosmic webs, filaments of dense plasma connecting bubbles around stars, a network invisible until pierced by a lone explorer. At first, skeptics attributed anomalies to aging hardware, but replicated measurements across instruments confirmed the reality. Plasma waves displayed fractal-like patterns, self-similar scalings hinting at turbulent cascades driven by the wall's energy. Researchers theorized that without this barrier, cosmic rays would bombard Earth unchecked, altering atmospheric chemistry and evolution itself. The discovery wasn't just of heat or alignment. It was of resilience. Our sun carving a defiant haven in the galactic storm. Back in mission control, the latest packets unveiled predictive models. The wall's temperature fluctuations aligned with heliospheric models refined in real time, forecasting boundary shifts that matched observed cosmic ray modulations on Earth. There was no doubt. This wasn't passive drift. Voyager 2 had unveiled a living boundary, responsive to stellar breaths across vast distances. In a coordinated effort, neutrino detectors and radio arrays triangulated echoes from the wall, mapping a persistent flux that synchronized with Voyager's deepest readings. Impossible under old paradigms, neutrinos streamed in patterns reflecting compression beyond the heliopause. When plotted, they formed a geometric envelope, not random, but curved in harmony with magnetic draping. It wasn't isolation, it was integration, our system embedded in a larger flux. In May 2025, Voyager 2 registered pulses coinciding with enhanced plasma densities, breaches where interstellar material mingled freely. These weren't failures. They were exchanges, the boundary yielding to allow equilibrium. The patterns overwrote assumptions, injecting new parameters into heliophysics models long held sacred. As readings evolved, audio translations of plasma waves yielded harmonics resembling deep cosmic resonances, frequencies tied to galactic rotation. The signal adapted, mimicking environmental shifts as if attuned to the medium it traversed. Introduced into simulations, it refined boundary predictions beyond current theory. Voyager had returned not just data, but insight into a thinking cosmos. The thermal wall, that blazing impossibility, now stood as guardian and gateway. Telescopes trained outward detected aligned fields extending from known stellar neighborhoods, symmetrical and stable, radiating in intervals echoing the probe's crossings. Something vast encircled us, tuned to the sun's rhythm. Finally, the profoundest revelation came quietly. Radio arrays captured layered harmonics from the boundary, not noise, but a symphony of plasma interactions synchronized with Voyager's traversal. It wasn't emission, it was resonance. We explored, and the cosmos resonated back. We launched Voyager 2 as an emissary of wonder, a beacon of inquiry into the unknown, a symbol of our reach beyond the familiar. But now, after 45 years, it's not us probing the dark. It's the dark revealing its form through us. The discovery isn't an anomaly. It's not a barrier alone. It's not even boundary physics as we knew it. It's a testament to interconnected scales, of heat forged in compression, fields aligned in harmony, plasmas dancing at the edge of stars. It shields worlds, filters rays, echoes outbursts, and structures the void into something profound. But the truth is deeper still, because perhaps Voyager didn't stumble upon impossibility. Maybe it was guided to illuminate what was always there, a cosmic architecture waiting for eyes bold enough to see it, or humble enough to listen. And now that we've measured the wall, traced the alignments, and felt the resonance across the gulf, we face one enduring question. Did we just uncover the universe's hidden firewall, or did we awaken to our place within its greater design? Whatever the answer, Voyager 2 has pierced the veil, and what it revealed is no longer beyond us. It's woven into everything we are. Subscribe for more revelations like this. Comment your thoughts below. Share to spark the wonder in others, and ponder deeply what lies at the true edge of home.